Hello everyone, welcome to Chaudhary Data World channel. Today I am here with new topic that is lazy evaluation in Spark. So this is going to be a very short video in which I will be explaining what this lazy evaluation is, where it is getting into the picture in Spark. So all these things we will be watching in this particular video. So let's get started with the video. So here lazy evaluation is nothing but suppose if you are having the difference between the Spark data processing or the on-premise data processing, like if you are data processing into your pandas library or something like that. So difference between both of them is that in Spark you are getting the things faster and you are able to handle a large data set. That's the basic difference between both of them. So how this is getting even executed, that it is getting parallelly processed in Spark. The data is getting parallelly processed. So this is parallelly processed and it becomes fast in consecutive to it. So how is it even getting done? So that is done with the major concept of lazy evaluation, which implies that suppose if you are having some transformations applied into your data set, in that data set suppose there is transformation like filter or it's grouped by, all these things getting applied in some particular data frame. That data frame, it is getting converted to RDT, and then on that all the transformations is getting applied on the Spark worker node. If you are aware of a Spark worker node and all, if not, then you can just check out my that video in which I have already covered up that architecture of Spark. And in that architecture of Spark, I have explained that what is worker node. Let me recap quickly so that if you here in architecture of Spark, you can see that we are having driver program, then cluster manager, and then worker node. Worker node is nothing but the virtual machines on which our whole data set will be divided or partitioned, and then it will be executed over there all the transformations. So in this lazy evaluation, what it happens that when it goes to data goes to for the transformation, that goes in the form of suppose RDD. So RDD, if you can see here, right? So this RDD is over there. When you convert, you are having the another transformation. Suppose filter is applied to RDD1, then it will be created a new RDD, that is RDD2. And if suppose then another transformation, and that is map, suppose it is over there, it is getting applied, then it is converted to RDD3. So this whole transformations are getting logically mapped into the Spark, but it is not physically creating the output of data. So this whole mapping, it is kept inside, and whenever you call the action, if you are aware about the transformation and action, then whenever some action is getting called, this whole graph, which is you can see in front of you, that RDD1 is mapped to RDD2 with filter, RDD2 is mapped to RDD3 with map. So all these mappings or graph is getting submitted to the DAG scheduler. Now here new terms come, that what is DAG scheduler, which I will be explaining in the next video. So it is getting submitted for the, you may say that it's submitted for the physical plan. Right now it's the logical plan of whole of the transformations which you are going to apply on some particular data frame, and which you have given command over your data frame, that it is, these are the sum of the transformations to be applied on these data set. So that is when logical transformation or logical mapping or graph is getting created. That logical graph later on call, when action is called, it is giving you the result. This whole process of holding on the data till the action is getting called, it is called as lazy evaluation. That means it is evaluated when you call the action, not on the on instantaneous basis, that whenever you call the you just do the transformation, your data is getting generated. It's not like that. It is only when you call the action, then only the whole of the day whatever logical graph it is getting created, that will be submitted to the DAG scheduler. That DAG scheduler then will generate the output of the data which you will see into your system. So this whole process is called as lazy evaluation, in which there is one concept of this graph. This graph, it is nothing but a lineage. It's all called as lineage. Lineage is the recorded history of transformation applied to RDD or data. So this is whole about this lazy evaluation. Now it comes to that what its benefit. Why even we are doing this lazy evaluation, right? So that is because of two major reasons. The major reasons are, the first one is speed. Of course, speed will be the data processing speed will be, it becomes faster. Another, that is fault tolerance. If suppose if you are having some fault in your whole of the transformation, and if you want to retrieve that data, it is very easy to retrieve that data, since all the RDDs are separate RDDs, all the transformations are into separate RDDs, and all those RDDs are having mapping of the previous RDDs, that's where it was. So it just take up that previous RDD so that it can be whatever fault it has been generated, we can retrieve from the previous RDD where it was not having any fault. So these are the two reasons, main two reasons in for which we are doing lazy evaluation, and this is how the lazy evaluation works in whole of this part. Hope this is very clear to you, and if any confusion, let me know into the comment section. Thank you so much for watching the videos. See you in the next video in of DAG and then DAG scheduler. All these things I will be covering up. Yeah. Thanks once again.